This is the Quibble team who've worked on the AI-based product comparison app. The genesis of this project came about with being somewhat frustrated with the inability to compare two products on Amazon. There were lots of details on the page, but there was no way to clearly see why one product may be better than the other. We wanted to build an app that could take two product pages from anywhere on the web, whether those are different sites or the same website, get the content from those pages and use an LLM to compare and analyze the differences between those. So that's what we did in building Quibble. This is the Quibble app. So I'm going to go and grab some URLs of a couple of backpacks. And then here I have a set of comparison options. So if I want to compare on price or the features or the model or the condition or whether there's delivery or not, or what the terms of delivery are, I can select those. I can also add some of my own unique comparison criteria if I want. So let's say I want to know which one is more durable. And then I click compare. And so what's happening here while it's doing its thinking is that this React front end is connected to a fast API backend through a WebSocket. And the WebSocket's actually giving us a status update of what's going on in the backend. So it's gathered the two web pages. Now it's doing an analysis of the content that it's scraped, and now it's generating the comparison. And you should have the comparison momentarily, and there it is. So here is the comparison of the two backpacks that we wanted to know. It does give some details on, the durability. And so it gives me some details about each of the backpacks, some of the pros of each and cons of each. And if I want to, I can save this comparison, and it shows up in my saved comparisons list. You can see some of the past comparisons I've run, and I can switch between these comparisons to see those if I want to see what I've done previously. I can also clear all of those past comparisons and get rid of that. Lastly, we did implement an about page so that users can learn more about why we built this site, how we built it, who are the people who built it, our GitHub repos and our Docker images for deploying it, and just some information about where it's deployed in Google Cloud.
Hi, Edward here. My part of the project included the front end setup. I developed and implemented the front end UI components, which included the two URL input fields, the drop down to show additional comparison options, and the compare button that connects to the backend to retrieve comparison results. I also displayed the results, designed and implemented the component that displays the comparison result to retrieve from the backend to include a concise summary at the top and the side-by-side comparison of the product's pros and cons. For the backend, I use structured output to ensure the OpenAI API response consistently returns the essential data fields needed to display in the front end, which are title, detailed pros and cons of the compared products, and a summary. The technologies I use is React for the front end framework, chosen for its component-based architecture that facilitates code reusability and scalability. The front-end components was created with Mantine UI, selected for its customizable components and offers out-of-the-box designs, which simplifies creating visually appealing user interfaces. For the backend, I chose Fast API, which seamlessly integrates with Python and has asynchronous capability. Some deviations to our project included we had to modify the front-end design throughout development to accommodate new functionalities we implemented. For instance, an input field was added to the additional options section, and there was also changes to the presentation of the results as we switched to structured outputs. Some challenges I faced was transitioning to a structured output for the backend. This required a shift in architectural design. And to overcome this, I leverage existing code and maximize the use of reusable components to efficiently adapt to the new structure. In this project, I learned a lot, being able to work on both the front end and the back end. I had hand-on experience with the Mantine UI for front-end development, and I was able to learn to effectively use OpenAI APIs and integrate AI into projects.
Hi, this is Xinrei. So for my individual effort, what did was set up the first API backend structure and the Swagger testing tool to test API endpoints. Also, I initiated the prompt service structure to provide user an option to select categories and provide user preferences while they compare, which generate the comparison prompt sending to the OpenAI API service. And also, I implemented local cache method to save comparison history in a sidebar and added features to save and restart a comparison. Technologies, what I used was the Fast API for backend and Swagger testing tools, and also front end using React. Also modified scraping service from Playwright to Selenium. And for the next sprint, I developed backend prompt service to generate user choice. And I implemented comparison history bar with saving comparison history feature added through cache method, and also added some extra features like delete and clear all. For last sprint, I completed front end and back end README repos to showcase our product. For the original plan and some deviations, so originally our web scraping method was using Playwright, switched it to Selenium. As for some challenges, so we did experience some like merge conflicts and some code conflicts while we worked together. In the end, we addressed all these issues by active communicating and PR reviews. As for what I have learned throughout this process, so I learned a lot of hands-on software development practice with in an agile environment, and for specific technical abilities, I've learned Selenium web scraping service, and also learned WebSockets method, which we changed from HTTP request. Also, I learned to utilize OpenAI API in develop like useful tool.
My part of the project, I focused a lot on asynchronous web scraping. So trying to capture the contents of two different URL pages concurrently, which was something we did to help improve the latency of the app, because our first passes of this application were quite slow. I also did HTML cleaning. So once we get the HTML pages, stripping out all of the markup from those pages. I did switch the app over to using WebSockets rather than HTTP requests, so that we could message between the back end and the front end. And this allows us for the back end to send the front end status updates, but it also allows the user to be able to cancel a comparison while the back end is processing. I did the visual design for the application and implemented and standardized some of the use of the component library. So the technologies that I use specifically, the Selenium for web scraper, used Beautiful Soup to strip the content out of the markup, WebSockets for messaging between the Fast API application and the React application, Mantine React Component Library for the front-end components. Steps in development for me, I felt like it was kind of building out simple versions of things first and then iterating on those in each sprint. Initially, we were processing URLs in a linear fashion at first, which we ended up making to be asynchronous and concurrent to reduce the latency. Loading state wasn't tied to the backend at first. But then once we implemented WebSockets, that allowed us to actually take messages from the backend and show those to the user. Challenges that I faced, I found out that web scraping is a lot more difficult than I realized. We added new techniques and browser options to get past the majority of bot detectors. Getting multiple Chrome drivers to run web scraping concurrently without interfering with each other. It took a while, but finally discovered that web drivers are not thread safe. So we needed separate WebDriver instances for each URL that we were processing so that they didn't interfere with one another. Thus, obviously, I learned a lot about web scraping, the value of writing tests and using Docker containers for local environments. I think if we had done some of these things from the beginning, it might have solved some of the dependency issues that we had.
My major parts in this project were setting up our OpenAI API calls, so using completions to get a response for a comparison prompt that we send to OpenAI. Getting Google Cloud Run set up for deployment and hosting of our backend and front end. Implementing Docker, both for building images to run in containers to test locally, but then also to deploy to Google Cloud Run. In terms of the front end, I did do the About page. I ended up doing a lot of testing and redeployment of things that got added in over the course of the project. Primarily Docker I use to have consistent behavior running our app across, we have Mac and Windows users on our team, and then also as a deployed app. Google Cloud Run, we chose that because it's very plug and play with deploying and redeploying Docker images of our app. Google Secret Manager within the Google Cloud Suite is a very useful way to pass in environmental variables that we didn't want to be hard-coded or part of our GitHub repo. When implementing Docker, for example, I would do research and I would usually try to start with something very simple, not even our app, but just like a dummy fast API app, and make sure I could get that working, and then expand to our app and iterate from there. Retesting and redeploying frequently with changes was essential to catch any issues that arose with new changes to our front end or back end. And we were always going to use Google Cloud, but we chose Cloud Run over App Engine because it's just a little bit better fit with containerized workloads. Major challenges for me, when I was initially attempting to deploy our backend, I ran into some major blockers that I had to do a lot of research to get around regarding the architecture I was building images for, what Google Cloud expected versus my local machine. Likewise, for our front end, knowing what ports Nginx expects to listen on, and some interesting adjustments I had to make regarding how React apps want to work with environmental variables. What I learned primarily was Docker and Google Cloud Run, which is something I was really interested in, and I'm happy I got experience with that on this project. I enjoyed working with Fast API and in particular, learning some of what it enforces with structured inputs. And then just more generally, the rhythm of branching for every feature, creating pull requests for teammates to review and approve, testing other teammates' pull reviews or pull requests, and giving feedback and approving those, just getting in sort of the rhythm of working in a software team like this. In conclusion, a major challenge that Scott in particular put a lot of time into is how to get around ways that sites try to detect a bot is trying to scrape something from them. So IP rotation or further tools to sort of enable us to still get the content we're looking for product comparisons. A major rewrite to avoid the need to have to copy and paste URLs would be the ability to search within a site. So say I want to look for a product within eBay and search within the site. That would be a huge effort, but it would make the app a lot more usable. Rebuilding our app or repurposing it as a browser plugin. So as you're navigating Amazon, for example, you could add this product to your comparison list for later use. If we ever wanted to set up a more long-term history of comparisons for a user, we would need to implement some sort of auth so you tell us who you are, and then you can see your full history, not just a recent history saved in local memory like we have currently. Multiple product comparisons. So right now we just allow comparison of 2 products. We could allow the user to keep adding in additional products. And then a final idea would be some more visual flair to add to the app. So bringing back an image of the product as part of the comparison instead of just the comparison and pros and cons that we have today. So lots of room for improvement and extension in the future.